In lesson 3-4, we're going to be talking about prime factorization. We're also going to be talking about a couple of other things as well. I will admit this is kind of a packed full lesson, so have your good listening ears on for me here. We're going to start by talking about multiples. A multiple of a number is the product of the number and any non-zero number. So in other words, you get multiples by multiplying by that number. So if you wanted the multiples of 4, they would be 4, 8, 12, 16, 20, and they would continue on forever. It's infinite. Set of multiples are infinite. A number's smallest multiple would be itself. Okay? Least common multiple is when you have two or more numbers and you're comparing to find which multiple they have in common that is the smallest. We could never have the greatest multiple because we said it's an infinite set, so there could never be a greatest. So we're looking for the smallest multiple. So to find the LCM, we just list the multiples. And we'll look at an example. If we were looking for the least common multiple of 6 and 10, we would list the multiples until we find that they have one in common. So the multiples of 6 are 6, 12, 18, and so on. The list will go on forever. Remember, we get that by doing 6 times 1, 6 times 2, 6 times 3, 6 times 4, and so on. Our multiples of 10, 10, 20, 30, 40, and again it goes on forever. So we're looking for the one in common that is the smallest, and I have stopped our list at that point. It would be 30. So the LCM of 6 and 10 would be 30. So now let's talk about factors. Factors are opposites of multiples. We're looking for numbers that are divisible by. Okay? So a factor of 10 would be 2. Another factor would be 1. Every number has 1 as a factor. Another factor of 10 would be 5, because 5 goes into 10 without a remainder. Okay? A number's largest factor would be itself. So another factor of 10 would be 10, and 10 would be the largest factor that it can have. A prime number has exactly 2 factors. That's one of our vocabulary words. So the number 11 is prime because the only factors it has is 1 and 11. A composite number has to be greater than 1 and has more than 2 factors. So the number 4 is composite because 1 is a factor, 2 is a factor, 4 is a factor. So it has more than 2 factors and it's greater than 1. Here's our note. 0 and 1 are neither. They are not considered prime. They are not considered composite. They don't fit the definitions of those two things. Okay? So, prime factorization. Prime factorization is when you take a number and you write it as the product of its prime factors. You can find prime factorization by either doing a tree or a ladder. And we're going to look at those in just a little bit. This is where I usually get a few students that go, I remember those. I like those. A lot of people like the tree. Not as many people like the ladder, but you get the same result. So to find the prime factorization of a number, you can make a factor tree, and then you take all the prime factors that you end up on the branches with and show it as a multiplication problem. The division ladder, same kind of idea. You keep dividing by prime numbers that they both have in common until you don't have any more in common, and then you show it as a multiplication problem. Our last concept of this section is greatest common factor. When you're looking for the greatest common factor of 2 or more numbers, you're looking for the largest number that is a factor of both or of all the numbers. If they have nothing else in common but 1, then 1 is their common factor. There are 3 ways that you can find the greatest common factor. One of them is like finding multiples. You can list them all. List all the factors. Find the one that they both have in the list that is the largest, and that's your GCF. Or you could use a division ladder, divide both numbers by the same common factor, and keep dividing until there are no common factors. Then the ones that you've divided by, you multiply those together to get the GCF. The prime factorization would work the same kind of way. You would make a factor tree and multiply the factors they have in common. So let's look at a couple of examples. All right, if we were wanting to find the GCF of 24 and 16, the first way is that we could list them. The multiples of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now, it helps if you're making a list to make the list in number order like I've done here, but you'll notice that finding them, it's easier to find the 2 that you multiply together to find it. So you can do it either way, but it's a good idea to write your list in order. The multiples of 16 are 1, 2, 4, 8, and 16. So the one that they have in common that is the greatest is 8. Okay? Here is finding the GCF using a division ladder. And for some reason, they usually go down instead of up on division ladders. A normal division, you make the box on top. And it doesn't matter. You could go that way, by the way. So you put both numbers in your box, divide by a number. They both have 2 in common. And if you divide 2 into 24, you get 12. 2 into 16 is 8. They both can be divided again. So you make your box. Divide by 2. You could have divided by something else as well on this, but divide by 2. 2 into 12 is 6. 2 into 8 is 4. I can do it again. Divide by 2. 2 into 6 is 3. 2 into 4 is 2. Now they have no more common factors that they can be divided by. So what you do is you come out here to the numbers you've divided by, 2, 2, and 2, and you multiply those together. So you get 8. So see, we got the same number doing it that way. Now remember, another way to do it is to find the prime factorization by using the tree. So if we had 24 and we were going to be looking for its prime factorization, we'll also be doing 16. So we'll do this one over here. Remember to do a tree, we branch out. And the one thing about a tree that most people like the tree more than the ladder is that you don't need to use a prime number. We used prime numbers over here when we divided. We can use anything. I could do 2 times 12, but I could also do 3 times 8, or I could do 4 times 6. I am going to do 4 times 6. 4 and 6. Now neither of those numbers are prime, so they're both going to branch again. 4, I could do 2 times 2. Now both of those numbers are prime, so I know that those branches are going to stop. They're not going to branch again. What most people do when they get to that point is they circle the prime factor, and that's because when you're within a tree, sometimes the branches stop at different levels, and it's a little bit harder to find those prime numbers, so circling them helps. 6, we're going to do 2 times 3, and those are also both prime, so we're going to circle them. And my tree has ended. I have nothing else to branch off. This one, the circles aren't really necessary on this one because they are all at that same level. It just doesn't always happen. So let's do 16 now. Again, I could branch out to 4 and 4. I'm going to do 2 and 8. So 2 times 8. 2 is prime, So that's going to stop, but 8 is not. It's going to continue to branch. Okay, so we have 2 times 4. 2 is prime, so we're going to circle. 4 is not, so we're going to branch. 2 times 2. These are both prime, so we're going to circle. So now, our next step is to look and see which ones are common on the tree. So I have a 2 here, and I have a 2 here. So I can put down a 2. I have a 2 here, and I have a 2 here. I can put down another 2. I have a 2 here. I have a 2 here. I can put down another 2. Whoops. There we go. Now I have no more in common. I have a 3 here, but I don't have a 3 here. I have a 2 here, but I don't have another 2 over here. So that's where I stop. And then I multiply them together. 2 times 2 times 2. I'm going to get 8 just like I did with the ladder and just like I did with the list. So that's how to find GCF of both. Now, what I'd like to do next is talk for a moment about the idea that we skipped, and that was finding the actual prime factorization. So let's look at 24 as our example. We did our tree, okay, or we could even look at this and do our ladder. If we just looked at this part, this would be the 24 part of our ladder. Once you get to this point, this is your prime factorization, and you would write it as a product of that. I'm going to come up here and do it in blue. So 2, and how many 2's do I have? 1, 2, 3. I should be writing it with an exponent. So I'm going to put my little exponent up there. So 3 2's, or in other words, 2 times 2 times 2. And I also have a 3. So I'm going to multiply by 3. This would be the prime factorization, right here, of 24. You'll notice I would have gotten the same thing here on this part of the ladder. It's 2 times 2 times 2 times 3, or 2 to the third times 3. So what would 16's prime factorization be? 2 times 2 times 2 times 2, which is 2 to the fourth. And I don't even have to put anything with it because that's all it was. It was 4 2's, so 2 to the fourth. And you can even see that here in our ladder. We had 2 times 2 times 2 times 2. All right, that's today's lesson. I know there's a lot of information in here. There are a lot of problems for you to work on, so we'll be practicing those in class. Thank you.